Hi, I'm Dave Robinson, and welcome to another one of my screencasts where I'll be using R to analyze data I've never seen before. As usual, the data comes from the Tidy Tuesday project, an amazing project in R run by the R for Data Science online learning community. Now, this is a fun data set we're going to be looking at together, and I'm going to do something a little bit fun for it. So this data is a data set on cocktail recipes. So I'm a fan of cocktails, so as I said, I'm going to try something that I've really never tried before. I've been live screencasting my code a couple of times. For this, I think the 6th or so time of doing a live screencast, but I haven't tried this before, which is, has anyone ever heard of Drunk Shakespeare? And Drunk Shakespeare is a show they used to put on in New York until the virus hit, where an actor takes 5 shots of whiskey and then performs a Shakespeare play from memory. So naturally, it's seen whether people can, how well people can, talented actors can do under a handicap of having a bunch of alcohol first. Now, I'm definitely not going to have 5 shots of whiskey. But I am going to have my favorite cocktail, which is an old-fashioned. So here I've just made myself. Actually, if you check my Twitter account, I just posted a picture. I made myself an old-fashioned out of Bullet bourbon, Angostura bitters, and a bar spoon of simple syrup. So we're gonna see how I do coding while drinking a cocktail. It's only about a 2-ounce pour. Wasn't planning on getting drunk and screencasting, but I've never really coded while having cocktails before, that I can recall, so this is going to be a new experience. Let's see how I do. All right, so I'm going to try. Oh, that's good. It's been a while since I had one. All right, so this is all right. So we're going to do screencast. I'll let you know how the drink is going and how it's affecting possibly my code. All right, let's get started. So we have the data with Tidy Tuesday. I'm going to go ahead and install the newest version of Tidy Tuesday R. My understanding is there's a new version up on GitHub. I should have said also, feel free, if it's appropriate time of day, if you're and if you're feeling it, feel free to join with your own beverage of choice, alcoholic or non-alcoholic. Definitely let me know in the comments what you're joining with, and maybe we'll bring up some recipes for that if anyone's making a drink they're interested in talking about. Oh, look at me installing reinstalling all the packages. Probably should not have said yes to it reinstalling. That's going to be fun. Let's skip the updates and just cross our fingers. The story is that then we'll load up the data from today. So library Tidy Tuesday R, library tidyverse, and as you know, I like to do theme set, theme light from ggplot2. So we're then going to pull in the Tidy Tuesday data, and we can take a look at it, the help on it over here. Once this finishes installing, we'll see how this does. This is charming, taking a second to, oh, look at that, reinstalling dplyr. That's, finally it got to it. All right, so that's my fault for saying yes to the installations out of habit. I probably should have just installed it in advance. All right, so now we've got our Tidy Tuesday data. We pull it in for cocktails, and here's our guide, and we can keep this open as we're looking through it. Let's see, and oh, it looks like other people have done some clustering. We're probably going to do some clustering, maybe principal component analysis today. So I brought in the Tidy Tuesday data. Let's look, there's 2 data sets, one cocktails, one Boston cocktails. I don't know the difference. Mr. Boston is cleaner, closer to analysis ready. Okay, I'm going to start with Boston. Last week I did a lot of data cleaning, and last week I did a lot of data cleaning, so I'm going to do Tuesday data, Boston cocktails, and I'm going to save that as Boston. I don't know what Mr. Boston, and the other one was web scraped. All right, and we'll take a look at it. So there's names, category, so it's 1 observation per ingredient per drink. That's really, that looks perfect. So then what I can then say is I use my favorite function of count, count name, sort is true. All right, the top one is academic review. I like that. No drink has more than 6 cocktails. Pardon me, no cocktails more than 6 ingredients. And what are the most common ingredients? That's going to be an important one. Ingredient. Most common one is gin, lemon juice, going to simple syrup, vodka. Okay, and I wonder if there's a breakdown here where there are categories of ingredients. Something like do we see anything here? No, the categories are the drink level, and then the ingredients here are. I'm just wondering if like all the whiskey. So there's bourbon whiskey, which is what I'm having. Bullet. There's straight rye whiskey. There's blended whiskey, blended Scotch whiskey, and so on. So the I'm going to keep that, and what I'll do is I'll say head 10 ggplot. We'll put on the y-axis the number of times, and the x-axis the number of times, the y-axis the ingredient. Ingredient. Genome call. I don't need a coword flip, but I do need a reorder. What I'll do is mutate ingredient, FCT reorder, ingredient by n. And we'll say, what are the most common ingredients? I can do more than 10, let's do 20. So here we have by ingredient, and I'm actually going to try one other thing in here. So this is most common ingredients. But I also saw there was a title, most common ingredients in Mr. Boston recipes. I also saw there was a title. There was a category. What are the most common categories? Well, if I try a distinct name and category, then I can count categories, sort equals true, and say what categories have the most ingredients. Cocktail classics, vodka, rum daiquiris, whiskeys. All right, and one thing that tells me is I'm going to want to lump these. I'm going to lump them by the most ingredients they fit into, which is, I think it's pretty reasonable. And what I'll do is I'll redo this analysis. And now head is not going to, but I'm going to count by both ingredient and category. I actually say category and ingredient, just a little more intuitive to me. Head is not going to work anymore because head is going to be only the first 20 categories and ingredients. Here's what I need. I need to say category is FCT lump, category with the top 4 and then other, but also say ingredient is FCT lump, ingredient, and the top 20. And then I'll do a reorder. I can't use, no, I can use n as long as I aggregate it by sum. And then that is across all the categories. And fill equals category. What is the graph that I'm trying to make here? I'm trying to make a filled plot. Now, this isn't so good because notice there's another level. This is what I love about FCT reorder. It's so flexible. I say ingredient is not equal to other. Put that above the FCT reorder. And now I've got my top 20. And aha, we can see what are the top 20 ingredients. I'm actually going to clean this up just a little bit because I think it's a good looking graph. And say y is number of recipes. I should have put that on the x-axis. Said y is the ingredient. And the fill is the category. That's a good looking one. So, ooh, someone asked, how about Ramana Murthy asked, is it possible to see a dendrogram, category ingredients, and then like look at clusters of them? I think we definitely should look at clusters of ingredients, what ingredients tend to appear in the same drinks or the same category. We're absolutely going to be looking at that. I have a few ideas of how we will. But first I just want to take a quick look at this graph. And I didn't save yet. Cocktails. So, I love this graph. I'm going to love it even more when we say as number of, we do it as percentage. Because what I can say is number of recipes is n distinct Mr. Boston name. Separate number of recipes. Then I can, instead of showing n, I can show n over the number of recipes, put the x-axis on a scale x continuous labels is percent format. I never loaded scales. And yeah, instead of a number of recipes, it's now percentage of recipes. Yep. Percentage of all recipes across categories. This looks great. So what this is showing is that a large chunk of all categories, about 1 out of 6, about 1 out of 6 drinks have gin, in this data set have gin in them, and most of those are cocktail classics. We also see the cocktail classics pop up with the dry vermouth, sweet vermouth, and grenadine, and not so much. We don't really see. Yeah, we don't see lemon juice, simple syrup, triple sec we do, or fresh lime juice. We don't see citrus or other sweet things in the cocktail classics. So that I think is already really pretty interesting. All right, so this is the first analysis. Enjoy a bit more of the drink. Let's see what effect it has on my typing, which is already not really what I'm used to. Cancel, save. All right, so the next question we have is what ingredients tend to appear together? In this case, I'm not going to ask which appear in particular categories, though we definitely can look at that. I'm going to ask what ingredients appear in the same recipe. This is a great use case for my YDR package. YDR is useful for finding connections between groups in a data set that normally you would have to turn the data into a wide format like a matrix to discover. So in particular, it's got a very useful function called pairwise core. I'm going to find correlations among ingredients across by name, that is by recipe, and say sort equals true. Wow, did I? I need to update YD. I need to update the YDR package. I did not know I needed to do that. I thought that I already had. Well, the YDR package needs to be updated, but here we see a combinations of particular drinks. We have pepper and vinegar. There's never a drink that has vinegar but not pepper, or pepper but not vinegar, though who would mix those two things? Who would put those in a cocktail? Well, we'll see. Similarly, apple slice and apple cider. There's an issue with these, which is they might only appear in one drink. I'm going to try removing those. I'm going to say add count ingredient, filter, n is greater than or equal to, let's say you must appear, so must appear in 10. Add count, a shortcut for group by ingredient, mutate n equals, and like the count of things. So here we go. I only have ones that appear in at least 10 recipes. By the way, how many things appear in at least 10 recipes? Lots, like 60 something. 70 ingredients appear in 10 recipes, so I can look at so yeah, these definitely have plenty of data here. All right, so these are some correlations, and I'm going to move it the threshold a little lower. Okay, and what I see is there's light cream if desired, whole egg, and so on. I wonder if there's ones with light cream but not if desired. We need to go through some standardization. Coffee flavored brandy and half are a close match, and so on. So the let's see. Yeah. So if we look at the these pairs of ingredients, I'm going to call this. Somebody shout out on the chat what their favorite cocktail ingredient is. I'm already going to go ahead and put one of my favorites, which is, let's see. Well, actually, I'm going to start with one of my favorites is gin. So we can see what are the ones most correlated with gin, and we can say. Filter for gin, and I could even visualize item 2 correlation geom call code flip. Nope, don't do a code flip anymore. I can actually put correlation to the x-axis. This. Let's see. I'm going to do head 10 and mutate. Item 2 is FCT reorder item 2 by correlation. Here it is. And now we can say is what is most correlated, what ingredients are most correlated with gin. So there's no surprise that dry vermouth is at the top, because dry vermouth combined with gin is a martini, and there must be many variations of martini in this data set. So we're going to look at another favorite one. My old colleague Jason Punyan has suggested tequila, as I thought he might. And I'm going to say, what if we look at both at the same time? Don't just look at gin, but also look at tequila. I'll need to switch the this from being a head to a group by item 2 and top n 10 by correlation. Now these are not going to be in the right order. Oop, nope, they're going to be a complete disaster. Item 1, group by item 1. That's what I meant to do. Here it is. And now what I'm going to do is do facet wrap this data by item 1, by the drink that we're comparing. Now notice I'm going to say scales equals free, at least free y. Great. Now notice they are in a different order between the two graphs. Long-time screencast watchers will know the fix for this is from the tidy text package. Julia Silge has a trick for this, which is reorder within item 2 correlation by item 1, and then add scale y reordered. Here we go. Notice that tequila is fairly high correlated with hotshot tropical fruit liqueur, okay? Madeira, egg white, grenadine, egg yolk, but then it kind of drops off quickly after maraschino. All right, so I've got a couple other suggestions in there. How about mezcal? I want to add a fourth one, so someone suggested egg white. Let's put an egg white as a fourth one, and I wanted to put in, what did I want to put in? Bourbon whiskey. That's what I'm having. And let's put in vodka. All right, and this is like our most correlated with particular ingredients. You know, I like putting in egg white, but I'm actually I want to kind of go for like a classic set of liquors here. Let's put in rum, and let's put in triple sec maybe. I don't know. I was thinking like let's stick to the. Oh wow, there really is a drop off of recipes. There's so many of a couple recipes, and then it kind of really does drop off. Yeah, I really can't see. I was really kind of expecting to see other things pop up. I'll start with these for bourbon whiskey, tequila, rum. What's another common one? Oh boy, my brain's starting to go a little numb. Brandy. Is there no brandy in this data set? Maybe not. So I'll leave a mezcal. Someone suggested mezcal. All right, so this is then seeing like, I am missing something. What am I missing? Did I misspell one of these? 1, 2, 3, 4, 5, 6. Is rum nowhere in it? I think it might be too specific, the type of rum. They might break it down. So that's kind of worth noting. Someone did suggest absinthe. I wonder, absinthe makes the heart grow fonder. And here we go. Absinthe, we see it with, I haven't heard of the Demerara syrup, some bitters, a little blanc. Yeah, so we can see various other ingredients that get included. So this kind of gives a sense of like, okay, what pairs with a particular drink? We can imagine a lot of things we could do with this. We could make an interactive app where someone puts in an ingredient and it suggests a couple of other ingredients to include. But I'm going to think of a specific one, which is, let's look at this in clusters. Can we see any clusters popping up here? I see Angostura bitters with, it's kind of a whiskey thing, isn't it? I see agave nectar in both absinthe and mezcal. Does it pop up in tequila? Well, it surprises me. So some things are going to kind of be in common across multiple of these. Some things, there's kind of duplication here. We see fresh lemon juice and lemon juice. And one thing is those two will not, fresh lemon juice and lemon juice will not be correlated because if they're synonyms, they won't pop up next to each other. So that's actually something worth keeping in mind. Here's what we're going to do. We are going to cluster them, to visualize them in a network. We're going to use library gggraph. And in a bit, I think we should try deduplicating the ingredient names for sure. Some people have pointed that out. I'm going to start by creating a network graph. Let's see. All right, I'm going to say, here's our ingredient pairs. I'm going to say, let's look only at head 200 because they're in both directions. It's only the 100 closest connections. And I'm going to do library iGraph. This is the way that I learned how to do it. What I'm going to do is turn this into a network. I'm going to say graph from data frame. Those who have seen a lot of screencasts before have seen me do this exact one, which is gggraph, a truly wonderful package from Thomas Pedersen. And the geom node, geom edge link, geom node point. We can see networks. Is this the? I kind of like the FR, which I can't remember what it stands for now. I kind of like this kind of network. It's not very useful until we've added labels, is it? So let's add geom node label and say AS, what is it? Nope, not label, text. Label equals name, and let's say repel equals true. I actually added the repel equals true feature in a pull request way back when. Really useful when you have too many things in your graph. This is still too many things. I'm going to reduce it a little bit. I'm going to show the top 75 connections. I'm also, am I going to filter for, I think I should filter for only a bit more common ingredients. Remember I had that greater than or equal to 10. 5, I'm going to make that greater than or equal to 10. I think that'll consolidate this down a little. I think maybe a little bit. Zoom in on it. All right, so this is now a network of types of drinks. What do we see? Here's a cluster of vodka-based drinks. We have vodka, fresh orange juice, coffee flavored brandy, etc. Pineapple juice, orange juice. Here's something I just thought about. Notice that when we look at an ingredient, some of them are primary ingredients. Some of them are at the top of the list of your ingredients. Others pop up lower in the list. And it just like kind of occurred to me, that's a way that we can, that's a way, look into this second, that we can kind of like add information to this graph. We might be interested in what are primary versus secondary ingredients. I'm going to do that, and then I'm going to come back to this graph to explore it a little bit more. Clustering. Primary versus secondary ingredients. Mr. Boston, we look at group by ingredient. And anytime I summarize it, I always want to include N. Now, we already did this with count, but I'm going to be doing a couple other interesting things. Somebody asked if I'm going to do PCA. I think I'm definitely going to be. I would love to do PCA. May or may not fit in today. We'll see. Principal component analysis, dimensionality reduction would be really interesting on this data set. Now I say ingredient, and we do the counts. Then I say, what is the average position? So mean of ingredient number. And notice gin is on average the second position, but simple syrup on average is in the 3.5 position. Now I realize some are in drinks that have a lot of ingredients, some are in drinks that have very few ingredients. Maybe I really want it as a percentile. That means that after doing group by ingredient, after doing group by name, I'm going to say group by name, I'm going to say mutate percentile equals row I think I can do percent rank is a function on, it's basically row number divided, the idea is like where does it fall within the graph. That didn't work as well as I was hoping it would. Why did that, what would be, let me take a look at this. Group by name, percent rank, oh maybe it's because of something that only has one drink. One ingredient. Yeah, okay, that seems to be the issue. I'm just going to do row number divided by n. I'm not going to try and be clever. All right. So so then what we can see is that fresh lemon juice is later in the recipe. Simple syrup tends to be like a later ingredient. Average position like 4/5 of the way through. And in fact, what I can do then is say ingredients summarized. I'm actually going to do one more thing because while I'm summarizing ingredients, I might be interested in the measure. So measure, look at this. There's like, I'm interested in parsing the measure. Some of them won't match anything, but some of them will be ounces, milliliters, dash, splash, drops. Yeah, I'm mostly going to say, let's imagine we only use ounces. Let's pretend for a second we're only using ounces. Then what I would do is I would do on this extract and then amount, so from measure, two strings, amount and actually just amount. And what I'm doing is an extract. Why? Because what I'm going to say is then I'll say regex is some amount of text, ounces. I get it someday. Here we go. And then 1, 1.5, etc. I really wonder, does anyone know a way to like reliably turn these amount strings, count amount? I'm leaving it as missing data if it's not ounces, if it's any other unit. I don't want to try converting dashes to splashes or anything like that. And the here we go, 4, 5. I'm really curious about this. Does anyone have a good idea? I can see 3 types here. Should I try and measure this? Are there only 3 formats? Unit, a ratio, and then a unit and a number and a ratio. Maybe. Okay. All right, I'm actually going to try this. I'm going to say extract out of amount. What I'm going to try to say, how do we turn this into a number? And this is a little bit of data cleaning. I don't think I've ever done this before. That's actually interesting. I've done a lot of these tricks on other datasets before. I don't think I've ever tried turning a string like this into a number. Let's see how I do. What I do is say extract for some number of digits from the start is 1, and then, let me see, I was going to say some number of digits from the start and then the end, or some number of digits from the start and then a space are the 2 types. And that's going to end up in a string called, in a column called ones, though it's the ones place. Here's the ones place. That looks pretty good. Because look at that. I can count measure and ones. And then I see so equals true. Okay, so 1 ounce, half an ounce has nothing in the ones place. This is a 1 in the ones place, and so on. And then I'm going to extract the fractional part. I need to add remove equals true. Remove equals false. All right, and then I do extract the ratio. So do some number of digits slash some number of digits, numerator, denominator, regex. Looking pretty good. Look at that, 102, 1, 1, 2, 2, 3, 4. I feel good about this one. Okay, so then I finally say ounces is going to be the ones place plus the numerator. So this has a mistake, which you'll show me in a moment. Plus the denominator. It doesn't work because of these zeros, so I actually can throw in a replace NA list. Ones is 0, numerator equals 0, denominator equals 0. And now, here we go. Ones plus numerator over denominator, and this needs to be like, we need to do safe division. If the denominator is 0, haha, so this is really close. I just need to say somebody had a good idea, which is if you're missing a denominator, make it a 1. Love that. Love that. 1.5. That's really cool. All right, so then we see measure, ones, numerator, denominator, and ounce. All right, not bad for halfway through my cocktail. All right, so I'm going to call this Mr. Boston parsed. Drop the count Thank you for whoever sets the denominator to 1. I may have gotten there, but not definitely not immediately. All right, and yeah, here's our 2 ounces, 1 ounce, 0.5 ounces, 1/4 of an ounce, and so on. Okay, so then I can say, Mr. Boston parsed, this, average position, average serving is mean of ounces, NARM equals true. Some of them are going to be are never going to be given in ounces, and that's okay. Those will just pop up. I actually don't see, where are the ones that are never given in ounces? That's a little odd. So the somebody said the from glass one isn't right. I think the from glass will end up being an A. So I think we'll be okay. Like if I did take this and I do, here we go, count, what is it? I'm feeling good about it. I'm going to leave it as it is. All right, so this is ingredients summarized. All right, and what I'm going to then do is look at, here we go, here's a graph. I'm going to say head 50, look at our 50 is too many, head 30. I'm going to compare the average serving with the average position and do it on a genome point. I'm going to size is the number of drinks. I'm actually going to do it over the n drinks. I thought that I computed n drinks somewhere, n recipes. And throw in a geom text repel on the library gg repel. Label is recipe, what do they call it? No, ingredient. Geom text. I only want size here. Somebody had a good point, which is if there's an NA. Somebody had a really good point. Thank you. If 0, so I actually need to replace some of these will be 0. So that was a really good call. Somebody pointed out if I did count ounce. Thank you. There are ones with 0, which is totally wrong. That's because none of these parsed. So what I'm actually going to say is NA if ounce 0. It's kind of the reverse of coalesce, or replace NA, where I'm placing the zeros with NA. And now if I look at ingredients summarized, some things are going to end up. You know, I said it would, and then, oh, there they are. There are some that are not a number. That's a weird one. But, yep. All right. Cucumber slices chop is going to be, for example, is not going to be in ounces. All right. Geom text repel. Thank you so much for that. Yes, thanks, John Harmon, for the fix of that, for pointing out that bug. Geom text repel. Where am I? N over N recipes. I forgot to put AES around this. What I'm then looking at is, let's add some, let's make this a little better. Y continuous labels equals %. And I am doing this format today. And then labs X is average serving size. You know, I kind of like to reverse these two. For some reason, I want average position in a drink on the x-axis. I'm not 100% sure why I do, but I'm going to put X and Y and say average position within drink. Change the scale at Y continuous to this. And look at, let's change the scale size continuous to also be labels % format. Size is percentage of recipes. I forgot a plus. All right, here's our recipe. Notice that when there's bourbon whiskey, it's almost always very early in the drink. It's kind of like where it is, so it's like It's one of the first things added. It's very early in the recipe. It's like a primary ingredient. The bitters are usually last. General bitters here, Angostura bitters, orange juice, gin, kind of in the middle. I did not expect that. I expected gin to be earlier. That interests and surprises me. And then we see our other primary kind of ingredients like vodka, rum, etc. Juice of a lemon being fairly early is not what I would have expected. Notice the average serving size tends to be heavier on the bourbon whiskey and lighter on the juice of a lemon, maraschino liquor. Triple sec is lighter. Like in a margarita, you have more tequila than triple sec. All right, that's a quick look at average serving size. Okay, I'm coming close to the end of my old-fashioned and to the end of my wits. If I look at the, let's see, if I already did the cluster. Oh yes, I remember what I was looking at. I was interested in where does it appear within a recipe, and I thought I could kind of use that. Take a look at ingredients summarized, and the if I take a look at ingredient pairs, here we go. This is the step I never figured out a really elegant way to do. Is I'm using my top correlations here, but then I can also say ingredient info, which is ingredient summarized filter for is the ingredient in the top cores, item 1. Top cores item 1 and item 2 are mirror images of each other, so I think I can just do this one filter, and now I've got the 59 ones that use it. And now I can say, I think I can do this. I can say vertices equals ingredient info in graph and data frame, and then make my points have a size equals n. How's this look? That looks pretty good. The idea is that like gin is at the center. It's really big one, a common one, and then there's rare ones around. I'm going to zoom in on this in a second, but I'm going to go a little bit farther. I'm also going to say color equals average position. Remember that we set up our average position a second ago. I'm also going to, I really like, for colors, I really like scale color gradient 2. Low is early. I'm deciding what is kind of meaningful. I'm going to say low is red, high is blue, midpoint is 0.5. I feel kind of okay about that. And I'm going to do a really nice little hack, which is that for anything around 0.5, I've just made this kind of graph a lot before. 0.5 looks kind of like a white dot. It's kind of hard to read. There's a little hack that I use for this. What I use is say under this point, I throw in 1.1 times this, and I leave the color as black. And I'm going to finish lighting this up a little bit. Size is percentage of number of recipes. Could use percentage, and I don't. Color equals average AVG position in drink. And I'm going to give it a name and say the universe of cocktail ingredients, and say subtitle connected ingredients tend to appear same drink, and say red ingredients are early in the same recipes. I'm going to call it constellations. I'm going to call it constellations. This is fun. Early in the recipe, and blue tend to be later. I'm also going to add in scale. No, in here I'm going to say labels equals scales percent format. Did I need a new line? I did not need a new line in here. All right, so this is what I'm doing right now for clusters of ingredients. And now let's try and get like a feel for this. Red. All right. So what is early in a recipe? Vodka starts off a red. Actually I really like. I wasn't quite sure what I would get with the red and the blues, but now I'm starting to understand it. The idea is heroes are set of vodka drinks. They always start with vodka. They are often followed by something like white creme de cacao, and sometimes late in the recipe you throw in a half and half. You could also throw in a cranberry juice, and then with that might come a pineapple juice or an orange juice. Those are all kind of mid to late ingredient recipe ingredients. Brandy goes in the middle of a recipe, all right. But what we see early, again, I don't understand how juice of a lemon is the first one. Maybe there's something arbitrary. Maybe there's something particular about that. It sounds very specific. But here's Blanco. Here we go. So the idea is like we see that from these red points, a lot of blue kind of spirals off of it. So here, look at a red and notice all the ingredients that come with it. With tequila comes curacao, agave nectar, Campari, fresh grapefruit juice. From light rum comes lime juice, fresh lime juice, simple syrup. Again, this is the kind of duplication thing of the lime juice and fresh and so on. From simple syrup comes Angostura bitters. Sorry, nope, that's not red. From straight white whiskey comes maraschino liqueur and Angostura bitters, though bitters is a late one in the drink. Can I increase the threshold? And is it going to be any better to do? Is it going to be better? Let me see. If I say, can I increase the threshold? Can I say top 200? I want to kind of just I want to squeeze as much detail, no pun intended, out of this graph as I can. I think it's pretty good. I think maybe the first one was better. Yeah, I'm gonna keep that first one there. Okay. So that was a story of creating correlations among. So notice the two things I did there. What's funny is I actually never used the ounces. I didn't actually use the ounces, though I might. Here's a quick one I'm going to do. I did average position within drink, but while I had the ounces, I kind of want to know what has the highest numbers. So if I say ggplot n average serving, why do we do n first? Because I don't want to be overwhelmed by things that have really low n. Label equals ingredient. Scale, I probably want the x-axis on a log scale for this one. And nope, not repel. Check overlap equals true. I don't necessarily want to show everyone. I want to show as many as I can. And v just 1, h just 1. Why am I doing that? To take it a little bit off the point. Expand limits. I kind of just want to show this. Here we go. So the question is, how big is your average serving? I just wanted to take a quick look at this since we did the parsing of the serving sizes, and it looks like, oh, you only add a little juice of a lemon, liqueur, etc. We don't even see the bitters in here because the that's a problem, isn't it? No, it's not a problem because I didn't graph the bitters, so the network still kept the bitters. But yeah, we don't see bitters in here. They'll be in dashes. We don't see slices in here. They'll be in slices. What we see are, okay, you've got your core ingredients: gin, vodka, light rum, Blanco tequila. Orange juice is not a core ingredient, not like a liquor, but it sounds like I added a lot. This is a mistake. Orange bitters probably should not have it. 1.5 ounces, probably a lot of orange bitters. Nope. Bourbon whiskey, orange juice, cranberry juice. Okay, so we add, what do we see that people add a lot of? Well, let's visualize that one other way. Then arrange descending average serving, head 12, ingredient. Flip these two around and do an FCT reorder. We've been doing lots of those today. Ingredient. And I'll say what ingredients have the largest serving size. Only ones that appear in at least 10 recipes. You know what I just realized? We needed to add something. I've got N in the ingredients summarized, but I don't have N ounce, N with, no, that's not the right place. I need to say N with ounces. N with OZ is sum, not is NA OZ. That really matters because otherwise we'll be including, if something has 10 recipes, but only one of them has ingredients, we would see it there. So ingredients summarized. What's funny is I feel after one cocktail that I feel like I'm coding well enough, but I'm not explaining myself well at all. But the I don't think I'm gonna make this a weekly occurrence. Average serving ounces. Y is ingredient. And change this to N with ounces. I don't know if that'll change anything here. It probably would remove all right. It didn't remove orange bitters. I don't know. I'm gonna just kind of hack it in. Oh, Angostura bitters too. I don't like any of that. N with ounces. Some not is an OZ. I don't know why the bitters appear in ounces. Maybe they're a third of an ounce of bitters, but then they wouldn't be up here. I don't know. All right. So the story is juices you add lots of, whiskeys you add lots of. The largest pours are of juices and whiskeys. That's pretty cool. We learned something from that. But again, what we discovered is we did ingredients summarized. We used that to take a look at average serving size per drink, the average position within drink, what got added earlier, what got added later. We looked at the average serving size, and then we looked at, here we go, and the John Harmon checked the data for me, and he told me that he tells us in the chat that orange bitters is always in ounces, 1, 2, or even 4 in the data. So it sounds like most bitters are given in ounces. Seems like a bug. So thanks for doing that. Thanks so much for doing that invaluable data cleaning, John. So it looks like, yeah, bitters is an issue, but that doesn't make a difference in this graph. This again is just average position in drinks, number of recipes. That is the end of my old-fashioned. I'm definitely not having another. All right, and what? All right, then we have about 10 minutes left. What are people interested in seeing? You know, we looked at, something, we want to look at PCA. So actually we have two choices. We can look at PCA or we can try deduping ingredients. I think PCA is going to be a little bit more interesting because it gives us a new insight, not just a cleaner version of data And honestly, the deduping is going to be a lot of, what's the word I'm looking for? Manual work. So I'm not going to do deduping. I'm not going to do that right now. What I'm going to do is PCA. We see some people like Louis Baden cheering for PCA. I'm in. Let's do PCA. In fact, let's do PCA the tidy way. There's a function in YDR, I believe, that I added this, called widely SVD. Good. The story is that PCA involves turning something into a matrix, performing singular value decomposition on it, and then turning it back. Now, if you want to see a really clear, lucid explanation of PCA, you might want to go, you can go to Julia Silge's talk, where she applies it to Stack Overflow tags. You can go to my video where I did, what did I do? Bob Ross, the Bob Ross paintings data set. The Bob Ross paintings data set, I did PCA on, and did I use widely PCA? I can't even remember. But I explained it then. I probably spent more time, and I definitely was in a better mental state to talk about it. So I'm gonna go ahead and do. What am I gonna do? I'm gonna do Mr. Boston. Yeah. I'm going to do PCA on this data, but I'm going to do it widely. What I'm going to say is widely SVD, where I say what is the item, what is the feature, what is the value. The value is going to be 1 by default. That is presence or absence. I don't know if I need to add a value. Let's find out. The story is I'll be looking at ingredients. The ingredients are my item. The features that I'm comparing across are recipes, the name, and I need to have a value. I'm going to add value as 1. That's annoying I'm going to also do distinct ingredient name. Yeah, I don't know why that I don't know exactly why that happened. All right, so but I think that there must have been at least one duplicate. All right, so the story is now I've broken the data down by dimensions, and I can say what is the first dimension, the second dimension, and so on in terms of the in terms of like the underlying properties. If I said like these two drinks are similar, these are the very two different kinds of ingredients, what would be the most extreme? Now I'll say ingredient SVD. Again, there are much better explanations out there. Julia Silgate, an amazing talk at one RStudio where she did this on Stack Overflow tags. And what I'm going to do is say group by dimension. I'm going to say filter dimension is less than 4. Group by dimension, top n 16 absolute of value. Nope. Value and ingredient geom call coord flip. I am making this in my head, and I think it's going to go ingredient reorder within ingredient by dimension, and then scale. I don't need a code flip anymore because I'm doing value ingredient scale x, scale y, reordered, and facet wrap. That was the one I was missing. I knew it was missing by dimension. I forgot the reorder within needs to say, oh, it's reordered by value within dimension. Okay. And I knew I forgot something else, which is scales equals free y. Yeah, so this is a quick story on SVD. On singular value decomposition, the principal component will almost always be the frequency. I don't know what I mean by almost always. It ends up being the frequency. Notice that the gin is just larger than anything else. That ends up being principal component number 1, 2, 3, etc. What I can do actually, can I center these? I think I can center them by doing mutate value 1, group by name, by ingredient. No, that's not going to work. That won't work, but I can just, because I don't have the ingredients I'm missing. I think that I can just do dimension is less than I'm just going to ignore the first dimension. I'm also going to say dimension is paste PC with dimension. Make the graph look a little bit better. One more way I'm going to make the graph look better is do fill is value greater than 0 and show legend is false. Have some green and red greater than equal to. This I've done a lot before. I'm going to add some labels. Principal y is ingredient. What are the greatest drivers? What are the sources of variation? All right. That's a possible title. All right. So here are the extremes. The idea of this is this is like what pairs of, you can kind of think of this as what pairs of ingredients, the source, what pairs of ingredients would never appear, not only never appear in a cocktail together, but never appear in the same type of cocktail together. So actually what I love about this is, notice, fresh lime juice and fresh lemon juice, they're probably not often appearing in cocktails, but they appear in the same types of cocktails. They're kind of interchangeable. They're both citrus. And so we see is at one extreme, gin. At the other extreme, simple syrup. So I think this is sort of like we're seeing our classic cocktails and our sweet and citrusy drinks. The vodka also makes it here, so it's not perfect. But like gin is definitely one direction. And then we see gin and dry vermouth on the other side, but against powdered sugar. See, this is where this kind of falls apart, is a juice of a lemon versus lemon juice. These are kind of representing similar things, though egg white ends up at a different end of this. Let's skip on this one. It's kind of like breaking down. This is where the ingredient duplication appears, is that we're seeing like the same kinds of ingredients, like juice of a lemon versus fresh lemon juice. Fresh lime juice Then the next one is PC4 is what type of citrus. So it's basically like once you've gotten out of the way, well, are you a citrusy drink? Are you fresh lime juice, fresh lemon juice? Which are you? Are you lime juice or are you lemon juice? And I think that's something really cool is this shows like once you've done the higher level orders of sources of variation, what else can you break it down by? Again, this will look better once we do ingredient deduplication. Last thing I'm really curious about is look at ingredient 2. I'm sorry, dimension 2. And just for a moment, I'm going to interjoin this with our, let's see. What I'm wondering is, I wonder if this principal component is really associated with classic cocktails. This, yes, yes. Jason Punyan pointed out what I want to do is look at the loadings. I cannot do that, not with this data set. I'm not going to do this right now. Yes, the question is, it would have been really interesting to see where the recipes land. I could have, I think, done that by reversing the, I think, yes. I think what I can do is recipe SVD. Let's actually try it. What I can say is recipe SVD name ingredient and here's my, there we go. And now my recipe SVD, I just replaced the times I said ingredient with name. I'm going to call it recipe here and say recipe. Yes, I think that's actually really cool. The problem is these will not match up with the other one that we were looking at, and there's more interpretation to be done here. It would have been really good if I could have compared the other one, but I can't do that with Wiley SVD. Okay, that's enough on principal component analysis. I just want to point out there's the ability here to really say what are the underlying types of drinks, not just like these pairs of ingredients popping up. All right, let's do one more review. Let's do one more review. So what we did was we looked at what the common ingredients were and how they popped up across classic cocktails. That gave us the idea that there were types of drinks. We looked at where things were in terms of position within a, oh, where did I do that view? I did it here. We looked at where things landed in terms of position, and that included some really cool text parsing with 3 steps of tidyrs extract. We looked at we compared average service sizing to average position within a drink to get a feel across these recipes, and we looked at what recipes had the largest serving size. Tend to be juice and whiskey. We looked at what ingredients were most correlated with a few of our favorite ingredients, and we looked at I must have done this filter must have gotten rid of some of those. All right, and finally, not finally, we did PC as well, but my favorite graph, we looked at the kind of whole constellation of cocktail ingredients using YDR and ggRAPH. And in the process, we learned I probably shouldn't be doing these, even with 2 ounces of bourbon is probably more than I can to be fully productive. But I learned that while I'm a little flustered, while I'm a little stumbling over myself, I definitely feel like we got a good amount done. Okay. So that was really fun. I hope everyone is staying safe. I hope everyone finds a chance to enjoy this data set, whether with their cocktail of choice or not. I hope everyone, if you do drink, drinks responsibly. And yeah, that's it for this week. I had a great time. I hope you did too. I'll see you next week.